Okay, it is Wednesday, February the 10th, and it's the afternoon of Wednesday, February the 10th. What we're going to do today is we're going to work on balancing reactions. So we said before, when we have a reaction, what happens is our reactants will rearrange to form something new. Why do we balance reactions? We balance reactions to show how to make the reaction optimal. So it will let a researcher or somebody in industry know how much of the chemicals to mix together to get the best reaction possible. Waste is bad in industry, and if you don't get the right mixtures, then you have some waste. How do we do it? You balance reactions by putting out numbers out front called coefficients to make sure that you have the same number of each type of element on both sides. Now, students sometimes will try and put subscripts in down here. You can't do that. And the reason is it changes the type of chemical you have. So for example, if I have H2O, that looks like this. If I have 2H2O, it just means I have that same chemical, but I have two of them. Now, if I put a number down here and call it H2O2, I have a totally different chemical. And you just can't change the chemical that's there. So you can only add numbers out front. Now, I'm going to go through about 5 or 6 problems, and then I think the best idea is to let you go. I've given you sheets with answers and let you practice, and you should be coming to me when you have difficulties. In the morning tomorrow, so starting Thursday, February 11th in the morning, you're going to get an online assignment to see what you've mastered with this. Now, I always look for the most difficult thing. So, these don't look the same, so I'm going to start there. If I have 2 Cls here, to get 2 over here, I put a 2 out front. You've got to remember how we count. That 2 goes with everything. So it means 2 NAs, 2 Cls. Whenever you balance something, look what it's attached to. So I balanced the chlorine. The chlorine's attached to an Na, so now I'm going to balance the Na. 2 Na, 2 Na. So if I was in a lab, I would mix 2 parts of Na with 1 part Cl2 to make 2 parts NaCl. I get lazy. I don't write the ones in. Technically, you should probably write that one in. Now, I'm going to show you the method or methods that I use. If you have methods that work for you, go with it. There's more than one way to get things done. Okay, so I'm going to jump around a little bit here. I'm going to do this problem right now. I pick something that looks out of sorts. So I'm going to pick the O2. So I've got 2 O's here. I need 2 O's over there. I will now balance what's attached to that O. 4 H's here. 2 times 2 is 4. 4 H's there. That's balanced. I would call this a simple one. What I will say is if you look in the package I've sent you, you're going to have answers to all of these. So you can try them and see if you're doing things right or not. If you're having difficulties, take a picture of 1, 2, 3, whatever it is, send it to me, and I will make a video of me balancing it. I'm going to jump to another sheet for a minute. The first difficulty usually comes up when somebody sees an even number on one side and an odd number on the other. So I've got 2 Cls there and 3 Cls there. Hey, let me say this again. Always attack what looks to be like the most complicated thing first. Here's another rule. If you start balancing and you get caught and it's not working, erase everything and start from scratch. Never try and correct something halfway through. If you get caught, you've got to erase and start again. So a simple rule is if you've got an odd on one side and an even on another, that's a Cl3, double it so you make it even. So I now have 6 Cls there and 6 Cls there. 2 Fe's, 2 Fe's. Just a simple rule. Okay, so now we've done the simple ones. We've done odd and evens. Let's take a look at ones with polyatomics. If you have a polyatomic, which is what we said was many atoms together, balance the polyatomic first and see if that works for you. So I have 3 SO4s. So pretend this is all one big thing. So ignore that 4 there. That SO4 is one big thing, and I've got 3 of them. So now I put my brackets around my polyatomics on this side. I've got 3 SO4s here. Balance what it's attached to. There's 6 H's, 6 H's. Now it's balance what that's attached to. 6 BRs. 3 times 2 is 6 BRs. 2 FE, 2 FE. Done. Okay, I want to balance a couple others to show you a couple other tricks. If you have one like this, you've got polyatomics. If you recognize them, it just makes your life easier. But you've got another polyatomic in here. You've got OH. If you ever have OH on one side of a reaction and H2O on the other, change your H2O into HOH. It will make your life easier. Okay, so but you need to have an OH on one side before you can use this rule where you take the water and change it into an OH on the other. I always like to balance my polyatomics first. One here, one here, one OH here, one OH here. That's done. Let's try this. 3 H's here. So sometimes you have to jump around to find what to balance first. 3 OHs here, 3 OHs here, 3K, 3K. Notice how I balance something, I look what it's attached to, and I balance that. This is a good rote way of doing this. I think I had one more of the basic rules that I wanted to show you. Okay. So, if you get a combustion reaction, this is where it's good to know types of reaction. It's carbon, hydrogen, oxygen. Balance them in that order. 2 carbons here, 2 carbons here. 4 hydrogens here. 2 times 2 is 4 hydrogens here. Now, you've got 4 oxygen here, plus you have 2 oxygen here. That's 6 oxygens altogether on the right-hand side. If there is an element that's shown twice on one side, leave that element in the balancing till the end, okay? So if you've got 2 of an element on one side of a reaction, you must balance that one last. We need 6 altogether. 3 times 2 is 6. There's one other one I wanted to show you, and it's when, I'm just going to do it down bottom. If you have an even number of carbons, you're going to run into an issue. I'm going to show you how to beat that issue. 2 carbons here, 2 carbons here, 6 hydrogens here, 3 times 2 is 6 hydrogens here. 4 oxygen plus 3 oxygen. Whoops, we've got 7 oxygens here. How do we get 7 over here? There's 2 tricks that you can employ. You can call that 3.5. Well, you might say you can't have 3.5 oxygens, but this doesn't represent 3.5 oxygens. It's 3.5 sets of oxygens. It's like having 3.5 cartons of eggs. If anybody ever tells you that you can't have halves or quarters in balancing, they're dead wrong. Okay, here's your next trick you can do. If you've got 7 oxygen altogether on this side, what you do is you go through and you double everything. 2, 4, 6. That would make 14 oxygens over here. 7 times 2 is 14. I would highly suggest that you watch this video a couple of times. A couple more points on things that people ask me. If there's a charge, does that make a difference? No. If they show states like gases, liquids, solids, what do we do with that? Absolutely nothing. Okay, make sure that you watch this a couple of times. Remember, all of the worksheets have solutions. Try the easier ones first and work up and see if you can give yourself a challenge. And by all means, if you're having problems, send it to me. I need a picture though, because there's a lot of sheets here. These sheets are all due. Just try some until you're good at the balancing.